Hey everybody, it's Mr. Carr again. Today we're going to be looking at 3.3 day one. This one we're going to go back to some factoring stuff, even though we've already done that. Gets to come back for this part of the unit. Okay, with our polynomials, remember, technically speaking, we've done this with quadratics. Quadratics fall into polynomials. So a quick factoring review. If we have a basic trinomial, like this one right here, we're going to look for what multiplies to the 6, adds to the 5. So we know it's going to look like this as kind of like a common sense idea. X squared has to come from X and X. Two positives has to come from two positives. And then what multiplies here but adds here, because that's going to work backwards. Like if I were to distribute out backwards, I want to make sure it matches up to the original one. So my numbers would be a 2 and a 3 here. If A does not equal to 1, like this 3 here, things get a little bit messed up. This one's not bad, but you can do either guess and check. So I'm going to do this right here, where I have to take 3x squared, needs to come from 3x and x. If I have a plus plus, I know it has to be a plus plus again here. And then my numbers here are 2. Now, keep in mind with the guess and check, it could have been 2, 1 or 1, 2. But the order matters because this is going to give me 3x and 2x. When I add those together, that's not 7x. So instead, I have to put 1 and 2 here because if I multiply that out, that's a 6x, that's a 1x, and that gives me 7x, which is what I want here. So that's the guess and check. Option number 2 is the AC method, which is going to be 3 times 2, giving me 6. And then you're going to multiply, what multiplies to 6 adds to 7 in the middle here. And that's going to be 6 times 1, and then because that's 6 plus 1 will give me 7. And then I have to do the 3x squared plus 6x plus 1x plus 2. And then from there, you're doing factor by grouping. So you look at them as 2 sets of 2. Either way, you're trying to get to this. And our last one that's going to be helpful for today is the difference of 2 squares. This is my pattern. As long as both of these terms are perfect squares, which I can take the square root of 9x squared, giving me 3x, and I could take the square root of 25, which gives me 5. Well, that means they can follow the pattern of this. So 9x squared minus 25, if I break it down as 3x and 5 as like these perfect square units, that means that this is going to turn into 3x minus 5 and 3x plus 5. So that's our factoring review when we did quadratics. With polynomials, we're just going to do it, but with a higher degree. So we've got some interesting things going on here. This is one strategy here. Find all roots, zeros, x-intercepts, etc. by factoring. So now we have it up to the 4th power, but there's a few things that we're going to do to make this easier. First thing is, I'm going to divide everything here by a 4. It makes it smaller and easier to work with. Secondly, I'm going to look at this. This looks very familiar. It almost looks like if I did this. If I did a squared minus 10a plus 9 equal to 0, I could do something similar with my factoring. This one's set up pretty well because a squared has to come from a and a. A positive 9 with a negative in the middle means that has to be 2 negatives. And to get the negative 10, it's going to be a negative 9 and a negative 1. So then I could take that and separate it. A minus 9 equals 0. A minus 1 equals 0. And then I just add that over to get a equals 9 and a equals 1. So that's something that looks very similar here. I can actually do that same process. The only difference is, and this works as long as my degree is double. I have a trinomial, so that's 3 terms, and I have the middle term, and the first term is like, it's double that, okay? So it's double the degree. I'm allowed to do this. I can still split it up like that. X to the 4th has to come from x squared and x squared. So instead of it being a squared is going to be a and a, x to the 4th is going to be x squared and x squared. Then my other numbers follow the same patterns. So I have a minus 9 and a minus 1. If I were to multiply this out, it still goes back to the original problem because that's going to be a negative 1x squared. This is going to give me a negative 9x squared, which gives me negative 10x squared. Okay, so that means I can still apply my zero product property. This times this equals 0 which means x squared minus 9 equals 0, or x squared minus 1 equals 0. From here, you could do factoring again. So I guess we want to stick with factoring, but honestly, I would probably do square root property. If you just add the 9 and add the 1 over, and they could square root both sides. But just to keep with the factoring idea, these are the difference of two squares here. So that means x minus 3, x plus 3 equals 0, x minus 1, x plus 1 equals 0. So shortcut on this one, this is just going to become x equals 3. This will become x equals a negative 3. This is x equals 1. And this is x equals a negative 1. Okay, so we're just solving it. So I'm going to leave it like this. But remember, if you graph this function, it's going to cross at 4 points. Negative 3, 0, negative 3, 0, 1, 0, and negative 1, 0. So it's going to cross 4 times on the x-axis. Some more factoring we can do. This one we got, so a little bit different of a case here. First thing is, just like with all our factoring back in quadratics, make it equal to 0. So I'm going to subtract x cubed over, or negative 18x cubed, I mean. So that's going to be 3x to the 5th minus 18x cubed plus 15x equals 0. Look for a GCF. In this case, it's x. Since I have x in everything, I can pull that out. I mean, x times 3x squared, or sorry, 3x to the 4th minus 18x squared plus 15 is equal to 0. Sorry, let me make that a little bit easier myself. Sorry about that. I was in the middle of, I actually could factor out more than just the x. So that's my fault on that one. I can actually factor a 3x out of everything. So if I do that, I'm going to have 1x to the 4th minus 6x squared plus 5. From here, I can apply the same things from last time. Because this is x to the 2nd and x to the 4th, it's double. So I can make it 3x times be x squared and x squared. If I multiply this, I multiply to a positive 5 and I have a negative 6 in the middle, that's going to be a minus 5 and a minus 1. From there, I can separate each of these through zero product property because I have 1, 2, 3 things that multiply to 0. So if I do that, that's going to be, I'll do up here, 3x equal to 0, x squared minus 5 equals 0, and x squared minus 1 equals 0. So from here, I'm going to show the square property in these cases. The first thing I'm going to do is divide by 3. So I get x equals 0 as one of my answers. For here, I've got x squared minus 5, so I'm going to add 5 to the other side. So x squared equals 5, and then I square root that. I have to move this down a little bit. Okay, so that's going to give me x is equal to a plus or minus square root of 5. And then for the last one, I'm going to add 1 to both sides. So x squared equals 1. So if I square root that, that turns into x equals plus or minus 1. So I have a total of 5 solutions here. I've got 0, I've got plus or minus root 5, and I got plus or minus 1. Just make sure you understand that's 5 total because of the plus or minus signs. Okay. Factor the polynomial here by grouping. So we've done factor by grouping with quadratics, but we did that with 4 terms. With 6 terms like this, I want to group it looking at, let's try groups of 3. When we do this, this only really works if I can pull something out of everything in a group. So for example, here, I've got 8ax, 4bx, and 4cx. All 3 of these have an x in common. They also have a factor of 4 in common. So I should be able to pull out 4x from everything. If I do that, I'm going to have 2a left over plus plus b plus c. For the next one, I've got 6ay, 3by, and 3cy. Again, I got y's and everything. And 3, 3, and 6 have a 3 in common. So I'm going to pull out a 3y. So then I can do that. That's going to leave me with 2a plus b plus c. From here, just like we did factor with grouping in the past, these two have to match up to do the next step. So that tells me I can do this. I can put the 4x and the 3y together. Oops, 4x plus 3y. And then I'll have 2a plus b plus c as the rest. And that's as far as I can go with that factoring. Okay, so officially this is a polynomial. It's not really one we can graph, but we can show the factoring still with that. okay? And last one here that we're going to cover in this lesson, factor this polynomial using the difference of two squares. Again, the difference of two squares works as long as they are both perfect squares, which as of right now, they're not. But if I look for GCF, they both have an A in them, and then 202 have 2 as a common factor. So I can factor out 2 times A out of this. What I'm left with is x to the fourth, y to the fourth, minus 100 z squared. Now those are both perfect squares right here. So if I call a squared is equal to x to the fourth, y to the fourth, I can kind of square root that so that a is equal to x squared, y squared. We're basically going to take the square root of x to the fourth is x to the second power. Square root of y to the fourth is y to the second power. Same thing with 100z squared. That's going to turn into 10z. So this is going to be my b right here in my pattern, and that's my a. So that means I can do this as 2 times a times x squared y squared minus 10z, x squared y squared plus 10z. So that's some additional factoring we can do with our polynomials. We're looking still for some of the same patterns we've done. So with our factoring, lots of times these same things come up over and over again that we did with our quadratics. It's just going to be a little bit more complex now because we're going to have higher degrees that we're going to work with. But we still look for those same things. Difference of two squares. We look for factor by grouping. And we look for stuff like this where we can still do our what multiplies here but adds here, but everything's just in a higher degree. That's all. All right. That's it for today. Take care, everyone.